Hello. Hello.
Yes, sir.
Yeah, is it audible?
Yes, sir.
Right. Okay, just wait for a minute and then we will start. Okay, so we were discussing about the center of mass calculation, right? So, center of mass of the particle system we have calculated, and next we had to calculate the center of mass of the continuous body. Okay, so that is what we were calculating. Okay. Okay, so center of mass of discrete particle system is there. So then we will use the summation. Okay. And if it is the continuous body, then what we will do? We will use the integration to calculate the center of mass. Okay. Okay. So you assist. Okay. You message, na? Right? Chali, let's start now. So we are going to calculate the center of mass of continuous body system. Right? So this energy thing we have discussed in the last class, and then we were discussing about the center of mass. Okay, so center of mass we want to calculate. Then if it is a particle system, then what we will do it? We will use it m1 x1 plus m2 x2 plus m3 x3 divided by what? m1 plus m2 plus m3, like that. But if it is a body, then what we should do it? We should use the integration. And before doing the integration, we should first calculate for the element where is the center of mass. Like if I want to calculate the center of mass of a uniform rod, then what it will come? Let's see. Okay. So center of mass of continuous body. Okay. There is a continuous body and we want to calculate the center of mass of that one. The first example we are going to take it for a uniform rod. Okay, uniform, what kind of rod? Thin rod. Okay, thin uniform rod is there where the center of mass will come. This is what we want to calculate. Okay, keep in mind we are considering what kind of rod? A very thin rod we are considering in the question. Okay, so here this is the end about which we want to calculate the center of mass. Okay, so can you tell me where the center of mass will come? Mass of the rod is something m given to us, and length of the rod is what? L given to us. And another thing, this rod is what? It is a uniform one. Uniform means what? The distribution of mass is what? It is uniform. So can you tell me where the center of mass will come? So it will come at the midpoint. How do we calculate it? So first of all, what we should do it, should I consider an element? So it's a linear rod. So what I'm doing, I'm going to consider a small element of what length? dx length. Okay. So what is the linear mass density of the rod? If you are defining what is the linear mass density of the rod, lambda, if we write it, can I say that linear mass density means mass per unit length, right? So here total mass of the rod is m, total length is l. So what is the lambda will come here? So lambda here it will come by it will come. Okay. So now for a thin rod, if we want to calculate the center of mass, then what will happen? Then center of mass, if you want to calculate it, what we should do it? First of all, we should find the mass of the element. What will be the mass of element? dm. Is it going to be lambda into dx? Tell me. What will be the mass of rod? dm. dm will be equal to lambda into dx, right? Because L length has m mass, the unit length will have what mass? M by L. So dx length will have what mass? M by L into dx. Okay. So if you want to calculate the mass of the element, it will become linear mass density into the length of the element. Okay. Now, the element I have considered, it is just a particle. Na? It's a small element. So where will be the center of mass of this small element? At that point itself. So if you want to calculate the xcm, what you will do it? Integration of dm into dm into what? Dm into where is the center of mass of that dm element? The center of mass of that dm element is at x distance divided by dm integration. Remember the definition of the center of mass for a continuous body? See that? This is what we are using it in our question. Integration of dmx by integration of dm. Okay. Now just put the value. So dm means what? Lambda into dx into x, and denominator it will be what? Lambda into dx integration, isn't it? See that what it is coming, and x will go from where to where? 0 to L length. Here also what? 0 to L length. So if you integrate it, lambda is constant, it will come outside. X dx integration, x square by 2. Denominator again, lambda will come outside, dx integration, x will come, and if we keep the limit, L it will come. So after simplifying, what are we getting? L by 2 we are getting. So where is the center of mass of a uniform rod? So for a thin uniform rod, the center of mass will come where? At L by 2. Or you can say that the center of mass of a thin uniform rod is what? At the midpoint of the rod itself. So please tell me, clear this one? Please tell me, clear this one?
Yes, sir.
Right. So that is the center of mass of a thin rod, or you can say that thin uniform rod. Where it will come? It will come at the midpoint, it will come. Now, some standard shapes are there, like rectangle is there, okay, rectangular plate is there, square plate is there. So these standard shape, what will happen? Their center of mass will be where? At the geometrical center itself. Okay. So please keep in mind there is a point for a uniform object. For a uniform object. Uniform object means what? An object whose mass is uniformly distributed. Okay. So for a uniform object, right, center of mass, center of mass will be will be at the geometrical center, where it will be at the geometrical center of the object only. Meaning is what? Like if I have a ring, complete ring, okay? Uniform ring, where the center of mass will come? At its center. So here the center and the center of same. So if you have disk hollow sphere, okay, hollow sphere is also called as shell. Okay, hollow sphere is also called as the spherical shell and the solid sphere. Okay, so for these cases, what will happen? The center of mass will come at the geometrical center itself. Is that clear? Please tell me. For the ring, disk, hollow sphere, solid sphere, where the center of mass is, center of mass and geometrical center are the same thing. Next, if it is a ring, sorry, if it is a square, where will be the center of mass coming? The center of mass will be coming at point of intersection of this uh, square diagonals. Okay, rectangle is there, where it will come then? Again, it will come the diagonal intersection. Okay, this is the center of mass. So please keep in mind, if an object is having uniform distribution of mass, okay, condition is what? The mass distribution should be what? Uniform. So if a body has uniformly distributed mass, then what will happen? Uniformly distributed mass, the center of mass is where? It is at the geometrical center of the body. Okay. So for the ring, disc, hollow sphere, these are the places where the center of mass will come. Is that clear? Please tell me. But there are some cases which is not symmetrical, like if it is a semicircular ring, if it is a semicircular ring, then where the center of mass will come? So in that case, either we have to calculate it or it is a standard object. So you can also remember that one, that where the center of mass will come in case of what? In case of a semicircular ring or semicircular disc. Okay. So for semicircular, for semicircular ring, where is the center of mass? Can you tell me? Where is the center of mass of a semicircular ring?
2R by
Semicircular
pi.
ring means what? Center of, this is the center of the semicircular ring. And if you want to calculate for the semicircular ring, the center of mass will come where? From the geometrical center, 2r by pi will come. Okay, we can calculate it using the integration method. You can also remember that one also, because it's a very standard object where the semicircular ring, semicircular disc, that will be used at many places. Okay, so semicircular ring, where it will come? It will come at 2r by pi. Next is semicircular disc. Okay, so for semicircular disc, where it will come? So for semicircular disc, it will come 4r by 3 pi. Again, from where we are measuring? From the center. Where will be the center of mass? Center of mass is going to be 4r by 3 pi. We are going to have it. Okay. So to calculate the semicircular disk, we need to take help of what? The semicircular ring. And how do we calculate for the semicircular ring where the center of mass will come? Okay, let me write two more of them. Then we will try to calculate for the semicircular ring what will be the location. Okay, na? Result is what? 2r by pi. How that result come? That also we can derive it. Okay. Next one is hollow hemisphere. Okay, hollow hemisphere. You can say that, or you can also say that hemispherical shell. Okay, hollow sphere is also called as the shell. Okay, so hollow hemisphere, or what is the other name of that one? Its other name is hemispherical shell. Hemispherical. Okay, Hollow means what? There is no mass inside. From inside, what it is? Inside it is. So where the center of mass will come in this case? So here, this is the center, and this is what? The center of mass. So that is how much? It is R by 2. Okay. Next, one more is there. That is the solid hemisphere. Solid hemisphere means what? Inside the mass is distributed. Okay. Again, keep in mind, whatever the example we are taking, these are all the examples of what? The uniform body. Wherever the mass distribution is given, the mass distribution is given as the uniform mass distribution given in the question. Okay. So solid hemisphere, where will be the, just give me a moment. Solid hemisphere, where it will come? So for solid hemisphere, again we are measuring from where? We are measuring from the geometrical center. Okay, this is what? The geometrical center, and this is where the center of mass we have. So this center of mass is what? The distance is 3r by 8. Okay, so these are some of the standard object whose center of mass we have written. Is that clear? Now please calculate it how for a semicircular ring if it is a uniform semicircular ring. Keep in mind the important point, it is a uniform distribution of mass. So for a uniform semicircular ring, how it came to 2r by pi, just calculate it once so that if I take an example of non-uniform, you will be able to answer that. Okay. Or semicircular disk, we know that how it comes. If we understand the process, then for non-uniform distribution also we will be able to calculate that. Okay, so chaliye, let's calculate this one. Center of mass of what? We are going to calculate the center of mass of a uniform semicircular disk. Keep in mind, first thing, it is uniform, and the next one is what? It is a uniform semicircular disk. Uniform semicircular disk is given to us. Okay, so let's see where the center of mass will come. So if it is a, sorry, semicircular ring, let's first calculate it. Okay, because once we can calculate for the ring, then only we can calculate for the disk. So ring is there, so what kind of distribution of mass will happen? So distribution of mass is going to be linear. Understood? What kind of distribution of mass will happen? The mass will be distributed throughout the circumference of the ring. So here the distribution of mass is what? It is linear distribution of mass. Linear mass density will come. So in that case, what kind of element we should choose? At an angle theta, we should consider a small element of what? D theta. So can you tell me what is the length of this part it will come? This is small segment, this is small simple linear length. Can I say that it is going to be r into d theta? So if I write dm, dm means mass of the element. Okay, dm means what? Mass of the element. How much it will come? Let's say the linear mass density is lambda and the length of element is r d theta. So mass will come lambda into r d theta will. That is the small amount of mass this element it is having. Now, if I ask you this element, it's a small element, na? I can treat it like a particle. So if I ask you what is the coordinate of this one, this is the origin, right? This is the origin. You can take it to comma 0. If you write the coordinate of this one, is the coordinate is going to be x coordinate r cos theta, r sin theta, isn't it? Check it. X coordinate is what? R cos theta. Y coordinate is r sin theta. So if you want to calculate xcm, what you will do it? Integration of dm into what next? Integration of dm into x. Now what is x? x is actually the x coordinate of element center of mass. So element is a particle. So that particle center of mass, where it will lie? So a particle center of mass will lie at the particle itself. So that's why what I should write it, dmx by integration of dm. When I am going to do it, next step I will write dm into, what is the x? X means x coordinate of element center of mass, which is r cos theta, denominator dm. Now we will integrate it and we'll get our answer. So what is the dm? Dm, we have it as the lambda r d theta into r cos theta. Denominator, we have dm integration, that means lambda r d theta. And tell me where the theta will change. What will be the limit of integration of theta? So you want to cover all the small element. Then can I say the theta will go from 0 to 180 degree? To 0 to pi integration, 0 to pi integration. Now you simplify it and let's see what we are going to get it after the simplification. Okay, so if you simplify it, what are we getting? Lambda outside, r square outside, cos theta d theta integration, sin theta will come 0 to pi, denominator lambda r d theta integration, theta will come, limit from 0 to pi. So sin pi you will put it, it is also 0, minus sin 0, if you put it 0, means this semicircular ring center of mass, if I'm calculating, then what is the x coordinate will come? The x coordinate will come 0. That's why the center of mass will be along the y axis. This is what? Along the x axis. Clear? The x coordinate, how much we got it? We got it 0. Now same way I'm going to calculate the YCM. So what I will write it for YCM? dm into y by integration of dm. So dm, what is the y? Y means the element I have considered. That element's which coordinate? That element's center of mass y coordinate, which is actually how much? Which is r sine theta divided by integration of dm. Again we will put the value and then we will integrate it, right? So let's put the value. Dm means what? Lambda r d theta, and this is r sine theta. Denominator, what we have? Lambda r d theta. If we put the limit 0 to pi, 0 to pi, right? Simplify it. Lambda r square outside, sine theta d theta integration is minus cos theta, isn't it?
Minus cos theta.
And limit will be 0 to pi here. Denominator lambda r d theta integration, theta, if you put the limit, pi minus 0 will come. So if you simplify it, lambda r get cancelled out. The r we have here, minus is also there. Cos pi is minus 1. Cos pi is what? Minus 1 minus cos 0 is 1 by pi. So if you simplify it, what are we getting? 2r by pi. That's why x coordinate of center of mass is how much? 0, and y coordinate is 2r by pi. That means what? If this is the semicircular ring you have, this is the y-axis and this is the x-axis, then where is the center of mass is going to come? Center of mass will come at this point. And if you want to write it in the coordinate form, you will write the coordinate is 0 comma 2r by pi. If you just want to locate the point, write the distance, then you can write it as 2r by pi. So that's why center of mass of a uniform semicircular ring, it comes at what distance? It comes at 2r by pi distance from the center. Calculate it for the disk, semicircular disk. Okay, find it. Center of mass of a what kind of disk? Uniform semicircular disk. Keep in mind, the disk is what? Uniform. But if it is a disk, then what kind of mass density will be defined? Linear or surface? Tell me. It is a disk. So mass
Surface.
distribution will be what? Surface mass distribution will be there, or you can say that areal mass density will come. Okay, you can say that areal mass density or surface mass density. We write it by sigma. And what is the sigma? Sigma is mass per unit area. So if I give you a semicircular disk like this, find the center of mass of this one. Where it will come? It will come at 4r by 3 pi. Where it will come? It will come at 4r by 3 pi, where r is the radius of the semicircular disk. That will come at 4r by 3 pi. Please calculate it and check it. Is it coming or not? Just take 2 minute time. What kind of element you will choose it for the semicircular disk? So concentric semicircular ring, you will take it as your element. Okay. So your element should be like this. What kind of element you will take it? A ring element you will take. What is the radius of this ring element? R. What is the thickness of this ring element? dr. So what is the dm will come? Dm will come sigma. Sigma is mass per unit area. So to calculate the dm, what you need to do? You need to multiply the area. So what is the area you are going to multiply? Pi r into dr. Means if this semicircular ring part, this element, if you stretch it, it will look like a rectangle. What is the length of rectangle? Pi r. And what is the width of rectangle? dr. So that is the dm we have. Now, if you want to write the center of mass of element, where the center of mass of element will come? So your element is a ring, semicircular ring, and just now you have calculated that a semicircular ring has center of mass at 2r by pi. So if I write it, and can I say that the center of mass will only come in which direction? X, or only in y will come? Only in y will come. Because why? Because element x coordinate of center of mass is 0. So when you will integrate it, everything, it will be still coming 0. So that's why center of mass here, it will come in only which direction? Only in the y direction you need to calculate it. Okay. So chaliye, please do the calculation just a little bit and tell me what is the answer coming. How much are you getting the calculation? Final answer are you getting? Calculating or not? Please tell me.
Doing
See,
Yes, sir.
if you are calculating the YCM, what you will do it? dm y by dm. So dm, if you write it, it will come sigma pi r dr. What is the y?
Sir, 4R by 3 pi.
Right. So what is the y? Y is 2r by pi. dm integration. So sigma r dr. Sorry, sigma into pi r dr. है ना? Let's integrate it. अब small r will change from where to where? 0 to capital R, 0 to capital R. Now we will integrate this one, sigma outside, pi outside, 2 outside, pi outside, isn't it? 1, 2, r square dr means r cube by 3 will come. And denominator if you go, sigma outside, pi outside. R dr integration means r square by 2 will come. Simplified, sigma pi got cancel out. Next what we have, r square, r get cancel out. 2 goes in the numerator, 2 into 2, 4r by 3 pi. So this is what I ask you to calculate, okay? So please keep in mind that whenever uh, a body is given to us, we should take help of what? Integration to calculate the center of mass. Now, based on this, what you have learned, let me take an example. Till now, we have taken the uniform uh, semicircular ring and uniform semicircular disk. Let's take two example of non-uniform body. Okay, a semicircular ring is given to us. Please keep in mind this is what a semicircular ring. Okay, now here the angle theta is measured from here. Here linear mass density lambda is not constant. Lambda is given as lambda naught sine theta. Is it a variable mass density now? Where lambda is what? Linear mass density. What is this? It's a linear mass density of this ring is a variable. Now you have to find center of mass of the uh, semicircular ring. Okay, let's find the center of mass of the semicircular ring. Okay, Chali, please tell me how much is that coming. Okay, this is the theta. Theta is measured from this x-axis. Theta we are measuring from where? Theta we are measuring from the x-axis. So now they are asking in the question, what is the center of mass of this semicircular ring, which they are asking in the question. So first of all, what you have to do, you have to choose the element, right? So choose the element, right? Tell me how much is this coming? Getting how much is that coming? Even you calculate it, you will find out that x coordinate again coming 0. You will find out that x coordinate is again coming what? 0 only coming to us. So only focus on the y coordinate. Okay. From symmetry, you can say that x coordinate will come 0. है ना? From symmetry, we can say that x coordinate is coming 0. You only have to calculate the y coordinate. Okay. So what I will do it again. First thing I will do it at an angle theta. I am going to consider a small element d theta. Length of this small element will come r into d theta. Now if I write the dm first, I will write it lambda into r into d theta. Now I need the coordinate of this element. Coordinate of this element, you can see that the coordinate of this element is what? R cos. Let me calculate the y coordinate. x coordinate you will calculate it, and after integration you will find out it is coming 0. So tell me, what is the dm? Next, in with y integration divided by dm integration. Okay, now this is what we should do it. Let's put the value now. The dm means what? Dm means lambda r d theta. What is y? R sine theta divided by dm means lambda r d theta. Let's put the value and then we will integrate it. What is the lambda? As per the question, lambda is given as lambda naught sine theta into r d theta into r sine theta. Integration will go from 0 to pi. Denominator, lambda means lambda naught sine theta r d theta. Chलिए, simplify it. This integration also will go from 0 to pi. Simplify it. Lambda naught outside, r square outside. We have
Pi r
integration
by 4.
of sine square theta d theta. And denominator what we have? Lambda naught r outside, integration of sine theta d theta. Limit will be 0 to pi, 0 to pi. So little bit simplification we can do it. Lambda naught r, so it will get cancelled out. Only r will be left. So this is r into of sine square theta. What you can write it before integration? Can you write it sine square theta as 1 minus cos 2 theta by 2, na? Right? Limit will be 0 to pi, and sine theta d theta integration, that will come minus cos theta, है ना? And there if you put the limit, it will come minus cos theta. Limit will come from 0 to pi. Okay, simplify a little bit. R by 2 outside, 1. Okay, d theta is still there, na? Now r by 2 d theta integration, theta will come. If I put the limit, the pi minus 0, it will become minus cos 2 theta integration. You will do it, so it will come sine 2 theta by 2. And sine 2 theta, if you put the upper limit, sine 2 pi 0, sine 0 is 0. So numerator integration is this much, minus cos pi is minus 1, cos 0 is 1. So after putting the limit, am I getting here also as 2? So what are we getting? Pi r by 4 coming to us. Understood? So this is what the center of mass y coordinate is there. Do the calculation for x coordinate, you will get it 0 as your answer. See that. If you are calculating x coordinate, can I say only thing different I have to write it is this one? Tell me, if I'm calculating x coordinate, what I will write it? dm x integration I will write it, divided by dm integration, isn't it? And when you will put it x as r cos theta, see, it will become sine theta cos theta d theta integration. And if you do it for 0 to pi, that integration will come 0 for you. So that's why here also, if they ask me the question, what is the center of mass? I will say the center of mass will be which direction? Center of mass will lie on the x-axis or y-axis. It will lie on the y-axis. What distance from the center? From the center, it will be pi r by 4. This is actually the center of mass of this object. So please learn this approach. That the approach is what? That always take the element, find the center of mass of the element, right? Then if you are calculating x coordinate, then integrate with the x coordinate, है ना? Element, x coordinate of center of mass you should use. If you are calculating y coordinate of center of mass, integrate with the y coordinate of the element center of mass. Okay, one more example. Let's do it on the integration part. Please tell me, this part understood? A
Yes.
semicircular disk is given to us. Okay, a semicircular disk is given to us. And here, areal density is given variable. It is given sigma naught 1 minus small r by capital R. Okay, small r, capital R is what? Capital R is the outer radius or radius of this disk. And what is small r? Small r is the distance from center to the any point. Okay. So as the distance from center to different point on the disk changes, its mass density also changes. Okay. So again, find the center of mass. Center of mass of this. What kind of disk is there? Non-uniform disk. Okay, find center of mass of this non-uniform disk. Tell me how much is that coming? Calculate it once. It is again what kind of distribution? It's a non-uniform distribution. Here, the areal mass distribution is what? Non-uniform. It's not a uniform distribution of the mass. So try it and tell me how much is that answer coming? Doing? And Sushant, please join it regularly the class. Okay, now many time you're absent, right? Please join the class
Yes,
regularly.
I joined, but I don't know why it starts late.
Uh-huh.
I don't know why I cannot join on time. Whenever I turn on my Zoom, then it stucks my computer. Like,
Okay, okay, okay. Okay, you are joining little bit late. That's what you're saying.
yes, sir.
Okay, okay. Okay.
And sir,
So
do you also teach the CSAS exam?
I have to check it the exam pattern once. Okay. And we'll see if it is will be possible. I got your message, okay, na? But I was outside that time. So don't worry, I will just see that what is the exam pattern, right? And if it will be possible, then I will connect with you. Okay.
Yes, sir.
Right. You are planning for that exam also.
Yes, sir. Like, uh,
Mm-hmm.
actually, I don't have the SAT, so right now I'm just focusing on the other, like Hong Kong and China's universities.
Okay, okay. Okay, no problem. We will see that if it is possible. First of all, I have to see the exam pattern. Okay, now, I have not taken any class like that, but I will see the exam pattern and all the details, right? And what time it will be, then I will connect with you once. Okay,
Okay, sir.
right? Yeah, just give me 1 or 2 days time, and I will confirm you. Okay,
Okay, sir. Thank
right,
you, sir.
right. Charan solved that question.
No,
The mass density was given non-uniform, na? So again, you have to take an element. What kind of element you will take it? If it is a semicircular disk, then we should take what kind of element? A semicircular ring element.
yes, sir.
Okay, so write it now. Please try once. Okay, tell me how much is this coming? See, if you want to calculate here, again, what you have to do it, you have to start with the element choosing. Okay, so I'm again going to take the same type of element which we have been taking earlier, isn't it? Like this, at a distance smaller, what we are taking, a dr element. So what is going to be the dm? Dm is going to be sigma into pi r dr. This element has where the center of mass. So this element center of mass is at 2r by pi, isn't it? Element center of mass is where it is at 2r by pi, right? Because it's a semicircular ring element. So again, we should calculate the YCM here. So what I will write it? dm into y coordinate of the element. What is y coordinate of element? 2r by pi divided by dm integration. The dm value, if I write it, what I will write it? Sigma pi r dr into 2r by pi, and denominator what we have? Sigma pi r dr. Let's put the value of sigma है ना, before integrating. Sigma is a variable na. I have to put the value sigma naught 1 minus small r by capital R given to us. Next, pi is there, right? R dr 2r by pi, that integration from 0 to r, and denominator, if you write it, what you will get it? Again, same value you have to write it in the denominator also, isn't it? Because sigma value, again, you have to replace it before integration. You cannot take directly sigma outside. Earlier, you were taking sigma outside directly, because earlier the sigma was constant, but now sigma is not constant, so you cannot take it out of the integration. You have to write the value before taking it what out of the integration, the constant. So sigma naught 1 minus small r by capital R pi r dr. Here also integration from 0 to r. Now simplify it. So sigma naught outside, pi outside, 2 outside, pi outside. So what we have, 1 minus small r by capital R. This is another r, this is another r squared dr. Limit from 0 to r. Denominator, sigma naught outside, pi outside. What I have? 1 minus small r by capital R and another r and dr. I hope after that this simplification can be done. Check it and tell me. So if we simplify after this, what we are going to get it? Sigma naught cancel, pi cancel. So we have 2 by pi. Numerator. Numerator r square dr integration. R cube by 3 will come minus 1 by r. R cube dr integration to r to the power 4 will come. Denominator r dr. R square by 2 will come minus 1 by r. R square dr. That means r cube by 3 will come. Just a little bit further simplification will be required. R, that makes it r cube. R, that makes it r square. So you have 2 by pi. R cube by 3, R cube by 4. So 3, 4, 12 will come, and 4 minus 3. So R cube will be there. Denominator 2, 3 LCM 6 will come. 3 minus 2, R square will come. So if you simplify, what are you getting? R cube, so R will get 6. So 2 will come. 2, 2 will come. So what we are getting our answer? R by pi we are getting our answer. So please tell me, clear up to this? So sometime if it is uniform, you can directly use the formula of the standard body. If it is a non-uniform type, then what we should do it? Then in that case, we should take the element, we should find the center of mass of the element first, okay na? And after that, we should integrate it to get the center of mass of the complete body. So actually, that is the process. We have it everywhere. Okay, that whenever we have to calculate the center of mass of any kind of body, we should choose the element first in the body, calculate the center of mass of the element, and then we should integrate it to get the center of mass of the complete body. Okay, is that clear? Please tell me what we have discussed. Is that part clear?
Yes, sir.
So next class we will continue with the momentum part. Linear momentum, its conservation, when we can apply. Okay, na? So these things we will continue tomorrow. Okay, right?
Okay, sir. Yes, sir.
Right, Sushant, Sharon. Good night.
Okay,
Take.
so once you confirm and tell, sir, like you find it and
Yeah, I will just check it once. Okay, now what is the pattern and uh, type of syllabus, and then I can discuss with you. Okay,
yes.
right.